Hello class, it's Mr. Ng with a video to walk you through the math of your decomposition of baking soda lab. So here I have some fake data that I just kind of made up out of my head, but here we could do a little bit of math. So to figure out this box, we need to just first find the difference, right? This box gave us the mass of the test tube with the clamp, and here this is the test tube with the clamp with a little bit of baking soda in it, meaning it's got this stuff. To find the amount of baking soda, we just find the difference. Let me grab my calculator here. So 35.74 minus 34.52, and I have 1.22 grams of the baking soda. Fine. Here, this becomes our given. 1.22 grams of baking soda, NaHCO3, and we want this mass into moles. If you recall your dimensional analysis, to get into moles, we put moles on top. And then to get out of grams, put grams on the bottom. NaHCO3, NaHCO3. So now we just need to have some sort of conversion factor, the numbers that will equate to grams and moles. I know that every 1 mole, let's scroll up here, every 1 mole of baking soda is 84 grams. So let's go back down here, right? And I'm going to put 84 on the bottom. So now I just have to divide that number by 84. And I get 0.0145 moles of baking soda, NaHCO3, right? So now that we have these moles, that's good. The next question wants us to use the balanced equation, how many moles of carbon dioxide. We're staying in moles, but we're just changing the chemical. So here this becomes our given, 0.0145 moles of baking soda, NaHCO3, and we want to get out of baking soda, which is NaHCO3, and this question wants carbon dioxide, CO2. It's going to be a mole to mole ratio, and to find these digits, right, this one here and this one here, we need to go to the balanced equation. Let's scroll up. So here's our balanced equation. For every 2 baking soda, I have 1 carbon dioxide, right? You don't see the 1, but there's a 1 over here, right? 1 carbon dioxide for every 2 baking soda. So that means for every 1 carbon dioxide, there's 2 baking sodas. And I just have to now divide by 2. Every now and then I get one of you multiplying by 2, but the thing is, this thing is in the denominator, so you divide by 2. So now I have 0.00726 moles of CO2. We'll add a 0 in front so it looks nicer. So this is pretty good information. I could do that. I could use this moles twice in these next 2 problems. This amount of moles, 0.00726 moles of CO2, this is our given. Convert the moles of carbon dioxide, here it is, to grams. Well, that's a pretty easy procedure. We're going to go from moles of CO2 to grams of CO2. Now I know that every 1 mole weighs, well, let's look at our background information. Every 1 mole weighs 44 grams of carbon dioxide, right? That's just the molar mass. We found that by adding up all the molar masses in the periodic table. So here, 44, right? So now I just multiply that by 44, and I get 0.3195 grams of CO2. That's too many sig figs. So let's make it into 3 sig figs. So this 0.320 grams of CO2. Great, good info. This is what we're supposed to get. This is our theoretical value. Excellent. On top of that, we're doing a little bit of gas storage, so let's convert it into liters. So here, this is 0.3, are given here is 0.00726 moles of CO2. Every 1 mole of gas, it doesn't matter which gas, takes up 22.4 liters at STP. And this is what the question is asking at STP. So 0.00726 times 22.4. At STP, this thing takes up 0.163 liters, or 163 milliliters. Great. The last part of your analysis is to find the percent error. So here is my theoretical. We're going to need this number soon. But here, I pretended to remeasure. So it looks like I lost this amount. If I find a difference here, I lost 0.24 grams of CO2. What I was supposed to lose, 0.32 grams. So for percent error, the equation is theoretical minus the actual divided by the theoretical times 100. This always goofs you guys. Those are absolute value things. So I was supposed to get up here 0.32. 0.32 minus 0.24 divided by 0.32. Absolute value that times 100. So 0.32 minus 0.24 divided by 0.32. So I got 25% error, which is horrible. Feel bad. I hope that helps you, and good luck with your lab.